I will start then. Hello, everyone. Thanks for joining us on the what I believe is the final talk of this season's Open Eco Homes, so Cambridge Carbon Footprint. And it is retrofitting historic homes. And there's a panel discussion and presentation. And we've got a number of us here involved. We've got Annie Naughton, she's an architect and certified passive house designer from Keystone Architects. Paul Robson is the principal conservation officer from Greater Cambridge Planning. We have Madeline Foster, she's a retrofit project officer from South Cambs District Council, and she's joined by Orla Gibbons and Ellie Haynes as well. But project officer and development officer, both in the climate environment team, from South Cambs. We have Hans Haughton from 3C Building Control, and Fran Sutton and the Home Energy Officer in the background, who is super important and everything to do with Cambridge Carbon Footprint's Open Eco Homes. Got her to thank for this. And then there's myself, James Rixon. My role as founding co-director of Cambridge Retrofit Hub. So that's probably enough of the intros. I'll go straight into and hand over to Annie, who will start the first part of the talk.
Grand. Okay. We're going to have a break in the middle for a quick question and answer section, and then we will have a longer question and answer at the end. And if you could just pop any questions you have in the chat, Fran will be fielding those. So here we go. Let's give this a go. So, hello everybody. My name is Annie, and I'm an architect and a passive house designer, and I work for Keystone Architecture and Design. Tonight we're talking about retrofitting historic homes. I'm going to do a little intro to the topic and talk about kind of first steps and key principles involved. And then later in the talk, I'll give some examples of how we can achieve some of the results we're talking about earlier in the talk, and including some examples from my own house and some lessons learned from the process. We've got a great panel and a lot to talk about, so hopefully we'll keep you entertained. Next. First of all, we're going to talk about what we mean by historic buildings. And historic buildings doesn't just mean ancient castles or significant listed buildings. For the purpose of this talk, I'm considering buildings built before the 1920s or 30s, which is generally when cavity wall construction became mainstream. So we're talking about solid wall construction, also timber frame buildings, traditional types of construction like cob or earth structures. And it's important to note that these buildings could be listed buildings, or they could be in conservation areas, but heritage buildings are not often neither. I probably don't need to make the case for retrofit to this audience, but I will just make a few points just in case, particularly relevant to historic buildings. 20% of our current housing stock was built before 1919, and the fact that these buildings are still lived in and sought after demonstrates the quality, longevity, and adaptability of these typologies. However, they can face issues with damp and cold and mold, and so to continue to be lovely places to live, it's important that these places are retrofitted. With a bit of understanding of the principles and the building physics involved, these homes can be effectively retrofitted, bringing them up to and sometimes even above the standards of modern construction. In fact, as historic homes represent some of the worst performing of our building stock, they can often offer the biggest opportunities for improvement. The key thing is that the solutions for these types of buildings needs to be carefully considered, as modern buildings perform differently. So if we just apply the same techniques used in modern construction, that can cause problems for these types of buildings. And then the final point is that embodied carbon is a significant justification for retrofitting historic buildings. Embodied carbon describes the carbon emissions generated in manufacturing, transporting, and disposing of the materials used in construction. Existing building stock holds a lot of embodied carbon, and if we can retrofit instead of demolishing and rebuilding to modern standards, the embodied carbon stored in our historic building stock can be retained. So the first thing to think about if you're planning a retrofit is to make a detailed plan of action. And that involves thinking about what you want to achieve. If you understand the motivation for the project and set clear aims, you can make a retrofit plan that will deliver the results that you want. Think about your priorities, whether that's to reduce bills or to cut your carbon footprint or to create a healthier indoor environment. If you know your goals, your red lines and your priorities, it will help you decide what measures to undertake, but it also can help keep you on track if you encounter issues along the way within your project. This means that even if you have to adjust your plan, if you know what your priorities are, you can make sure you still achieve the goals you set out at the beginning. Think about your budget and also money included for professional fees, any consents you might need, like planning consent, etc., or if you have a contingency as well. It's important to consider a contingency with historic buildings because as you start to expose fabric, you can often find things that you didn't expect to be there and your plan may need to change. Think about phasing the work. If you need to spread the cost out, phasing can be a useful technique. Also consider whether you'll live in the house when the works are being done. This can help to save money, but can also add complexity and stress to the project. You will likely need professional advice from architects, retrofit assessors, structural engineers, energy consultants, mechanical, electrical engineers, Passivhaus designers, building control, to name but a few. And finally, think about how you'll measure the success of your project. Think about possibly saving maybe a year's worth of electricity and gas bills or oil bills. Think about taking thermal images before, so you can have before and after images. Some people will get an air tightness test before they start the project, so they can compare the air tightness of the original project, the original building, and the finished result. And also think about if you're going to undertake post-occupancy evaluation, which can be things like air quality monitoring and things like that. Once you've decided on the measures you will undertake for your retrofit, you need to understand if you need any permissions before you start the work. Coming up, we've got a section about conservation from the local authority and also a section from the local authority building control. So they'll go into a bit more detail about this. But first of all, I've got a few initial guidance points to bear in mind. If you're changing the external appearance of the building and the work does not fall under permitted development rights, then it's likely that you will need planning permission. If the house is in a conservation area, then there are further limits on the permitted development rights within conservation areas. If the building is listed, you will need listed building consent before undertaking any work. And it's worth bearing strongly in mind that it is illegal to work on a listed building without consent. And many types of insulation work require building regulations approval also. Now I'm going to hand over to Paul, who's going to talk about heritage conservation. So I'll hand over to you, Paul, and just let me know when you need me to change the slides.
Thanks very much. So yeah, just to say again, I'm Paul Robertshaw. I work for Greater Cambridge Shared Planning. So I'm Conservation Officer for Cambridge City Council and South Cambridgeshire District Council. And I just wanted to very briefly set the scene for heritage conservation, sort of adding to what Annie's just said. So within the system we work in, the National Planning Policy Framework, the conservation of historic buildings is in the same section as the sustainable development section. So it's very much seen as a shared objective. It's not heritage versus sustainability. It's a shared environmental objective, and very much the to just reiterate, the conservation reuse of historic buildings is inherently sustainable for the reasons already touched on. But it does bring with it a few extra restrictions, and very much the kind of movement, the conservation movement is now very old. It sort of originates in the 19th century when buildings were being sort of torn down and mutilated by the Victorians, and the movement sort of grew from there. But then also the post-war era, when there was a zeal for redevelopment and towns and cities were being redeveloped, the sort of listing system, conservation area system, grew out of there. So next slide, please. So we have heritage assets. So they're the buildings we're referring to, and designated heritage assets. They might be listed buildings or structures, and they would be in 3 grades, grades 1, 2-star, or 2. The listed building might also include curtilage structures, so buildings within its curtilage that are counted as listed as well. Conservation areas, registered parks and gardens, so landscapes, scheduled monuments that might be more ancient things, and a few things we don't really get around here. just the graph just sort of gives you a bit of an overview of how many listed buildings we've got across Cambridgeshire. Many thousands, so it's there are lots, and therefore there's a likelihood that projects people are working on will interact with listed buildings or heritage at some point. So we have our designated heritage assets. We also have non-designated heritage assets, and that would be perhaps archaeology or locally listed buildings. That's a whole other talk probably. But if I go to the next slide, please. So just again, quickly, just summarising what a listed building is. So it's a building or a structure with statutory protection, legal protection through the relevant Planning Act, and it's a building of special architectural or historic interest. As I say, they come in 3 grades of different levels. Grade 1 might be sort of nationally important, internationally significant, perhaps a cathedral or something of great merit, through to the majority of buildings of grade 2 that we come across. The listing covers the entire building, the interior and exterior, and it includes also structures in the curtilage which are older than 1948. And consent will be required for any works that affect its character. But that doesn't actually mean that all works will need listed building consent, and repairs and maintenance can often be agreed without any consent. We'd always encourage people to have a chat with us just to sort of work out what doesn't need consent, because there is a bit of a risk of proceeding without the necessary permission. And when thinking about what would be granted permission, there's a requirement to have special regard to preserving the building or its setting, and its features of special interest. So we've got a sort of duty to preserve the special aspects of these buildings. There are some links on there which you'll be able to follow later. And then on to the next slide. This is conservation areas. So this is obviously it's area based. So it's anything from a sort of small village centre, a group of buildings. In Cambridge, we have areas which are areas of terraced housing, and the spaces and the environment in between them. So it would include perhaps open space, a village green. A conservation area protects trees as well as buildings. And as I said before, this is something that kind of came out of the sort of post-war period. Our first conservation area was in Stamford, which is not too far away, and is probably considered quite special because it was protected early on, and is very much valued for that now. So again, it's a statutory designation. So we have duties to first of all, I say the local authority, duties to designate conservation areas, and then when considering development, to have special attention to of preserving or enhancing the character or appearance. So it's very much character and appearance of the area is the kind of key thing to think about, and just to bear in mind that the character and the kind of consideration is more than just what you see from the street. You would consider a bit more than that, including sort of back gardens or sort of more private views, but it's a sort of holistic protection, really. So that's my quick intro, but I'll be hanging around for any questions you might have later. So I'll let you crack on. Thanks.
Thanks, Paul. And next we're going to have Hans from 3C Shared Services, who has stepped in last minute to cover as the person who was going to talk was ill. So thank you so much, Hans. And here we are. If you need me to move slides, just let me know.
Yes, so yeah, good evening, guys and girls. Yeah, retrofit. Next slide, yes, please. It's straight into it. and it's the key thing to take away from this, because it can be quite complex, and even though buildings may seem building works may seem very similar to previous schemes, you need to get engaged with your local authority or your building control body at an earlier opportunity as possible. It can be quite complex because it depends on what the building currently, your current building use is, and what you're proposing to change it to, if that occurs. There are various requirements relating to various regulations that apply to it. So as you can see here, regulation 3, material alteration of a building. So if you're changing anything then associated with it, you may need to bring it up to standard. It depends on what your work you're doing as to what is required to be carried out. When you're depending on whether the work is a change of use or whatever you're proposing to do, you might need there may be various areas of the building regulations that would be applicable and would need to be considered. So there's no one size fits all. They're all on a case-by-case situation. What needs to comply? It depends on what you're doing. That's the main thing. As it says, it's now everything from A to T, depending upon the work that you're carrying out. Material alterations of a building surface, again, that's where when you're doing that sort of work, it kicks in a certain requirement. There are elements that regulation 22, 23 and 28, 22 requirements relating to change of energy state. So if you're changing a fuel, that may kick in a requirement. So you might not be doing anything, but you might be going from a gas boiler to a air source heat pump. Great, but there will be a requirement to think about how that works with the building regulations. The requirements relating to the thermal elements. If you're doing anything on those elements, how are you going to make that comply? Obviously, you need to think about the building materials. You can stick to conventions, but often these conventions or modern ideas and modern approaches don't work with old buildings. So you need to engage with your building control department to make sure that those materials are still in compliance with what you're proposing to do. Depending on the building work, again, if it's a commercial, there may be a consequential improvement for you to do certain things, but that's kind of not really for domestic that's more for commercial situations. Energy efficiency requirements, yeah. So conservation areas, they're not exempt from the building regulations. Only listed buildings could be, but then they still expect you to still show some approach or some improvement to the building that you're working on, if you're going to, and if that work is controllable. So it doesn't exempt you just because it's in a conservation area or on a listed building. You can, sorry, if we move on now to the next slide. The common, it's common, as I just said, the conservation are exempt from building regulations. They still need to comply. The energy efficiency of historic and traditional buildings should only be if they do not cause long-term deterioration of the building fabric, which is what we covered. So you do need to think about the materials that you're using, how that fits in with the building, and how that will not harm the building effectively. You can use competent person schemes to do some works in listed areas, but you've got to be careful about the competent person schemes, because whilst it is acceptable to use them, you might find that the competent person schemes do not permit within their own rules their use in conservation areas. So you might have a simple terrace house in Cambridge, located in a conservation area. You might think, well, we've got fencer certificates for my windows, but the fencer scheme might not cover that requirement. So you've got to be careful, interrogate the competent person scheme. If you go on to the next slide, I don't think there's, yeah, and that's the other thing. The approved documents may not be relevant for all your situations. It's a method of showing compliance, and sometimes they don't fit with the traditional housing stock. So you do need to think about how that works. Again, so that's pretty much what I've said. And the building work should really needs to comply with the building regulations, and it's not always possible to undertake the work in isolation. And so you know, if you're improving the insulation, you might find that, and the air tightness of a building, you might find that the air quality changes inside the building, and you might need to do something to offset that. So you need to think holistically about your approach to these things. And again, it goes back to the beginning. You do need to engage with your building control department or your building control body at an earlier stage as possible to ensure that you meet your obligations under the building regulations. And I think that, is there anything, another one after this? Sorry, next slide.
No, that's it. That's
yeah,
great.
then I think the next one, yeah.
Thank you so much.
Okay.
Okay, just to kind of bookend that, I've got a few links here, including a link to the Planning Portal Interactive Guide, conservation area appraisals, the National Heritage List for England, which includes the listings for listed buildings, and the links will be available when the slides are shared after the presentation, so I'm not going to dwell on this slide for too long. And similarly, a few of links to the approved documents that are particularly relevant with retrofit projects. And again, just a note to say, if in doubt about whether you need consent for things, the best thing to do is to reach out to professionals that are involved, whether that's architects, planning consultants, local planning authority, or building control, there to help. So reach out rather than work too far down the line and find out too late that you need to get consent for something that you don't have consent for. So the next stage of the talk is about kind of key principles to understand, and just to kind of follow up on some of the things that Paul talked about, I just got a little slide here about heritage value, and the kind of to make the point that it's important to understand the significance of your building. If it's a listed building, you can read the listing description, and if it's in a conservation area, you can read the conservation area appraisal to find out what the kind of notable features are. If you understand the specific case for your building, you can be sure that your proposals won't affect the things that make it significant, that are important to its characteristics from a conservation point of view. It's always good advice to avoid proposals that include the removal of historic fabric, if possible. And it's also worth bearing in mind that sometimes retrofitting can provide an opportunity for restoration. So, for example, it can include the removal of inappropriate concrete renders from breathable construction, or as in the photo here, where the owners took the opportunity offered by adding internal wall insulation to study and rebuild and then reinstall the historic mouldings in this listed building, which had been lost as they were removed by a previous owner. So, the next key principle to understand when we're talking about retrofit in historic buildings is breathability. And confusingly, when we're talking about breathability in buildings, we're talking about moisture movement and not air movement. This is important because construction build-ups in historic buildings were made with breathable components, which meant that they were constructed in a way that let moisture move through the structure without getting trapped. The diagram on the slide here shows the typical construction of a Victorian house with brick walls, lime mortar, lime plaster, timber structural members, and a ventilated sub-floor void, and a ventilated roof construction, which meant that air could move around the structural timbers, to prevent them rotting. The solid walls allow the moisture to penetrate and evaporate in both directions, depending on external and internal conditions. And additionally, ventilation through windows and doors, intentional ventilation, but also uncontrolled ventilation through chimneys and leaky construction details, helps to remove moist air from inside the building. So what does that mean? Okay, so what does that mean in the context of retrofitting historic buildings? It means we need to choose the right materials when we're insulating, and that means breathable insulation. This type of insulation will allow the building as it was originally built, allowing moisture to move through the structure and not become trapped, which can cause problems of damp, mould, structural damage, and reduced insulation performance. Natural building materials provide good quality breathable insulation and come in various shapes and sizes. Some examples are rolls of sheep's wool, as you can see in some of the pictures, wood fibre boards, and blown-in cellulose, which is made from recycled newspaper. It's important to think about the whole build-up and use alternatives to gypsum and cement-based boards where possible. There are lots of products such as wood-based boards for lining, lime-based plasters, hempcrete and cork-based render for external application. You can also buy breathable paints. And natural building materials have many advantages, including being easy to work with and non-toxic often, so they're good for DIY applications. They also tend to have low VOCs and also low embodied carbon. And it's important to note they often have additives to fireproof and insect-proof the materials. Additionally, they are important and different producers use different ones, so you can find specific information by contacting the manufacturers of different products. Slide here just with a few links to places where you can purchase and get advice about natural building materials. And then moving swiftly on to airtightness. And airtightness is a really important concept when retrofitting. And I often get asked if a building can be breathable and airtight. And yes, it can. And this is actually a really positive thing, both from energy performance and in terms of looking after the structure of your building. As buildings have become better insulated, uncontrolled air infiltration is now responsible for a bigger percentage of heat loss. And that can be up to 49% in modern buildings. And as mentioned, moisture getting trapped in the structure is generally a bad thing. This is not so much of a problem if you have truly breathable construction, but still it's best to be avoided where possible. And then just a quick slide on how this can be achieved. And I've got sort of two options that I'm looking at in terms of how you can achieve breathable yet airtight construction. Option one is for what are called variable surface diffusion membranes and airtight tapes. These are essentially types of smart vapor control layer, which respond to the conditions internally and externally and change their vapor permeability in response. Basically, it means as the temperature and the humidity changes inside and outside, the membrane will become more vapor open or more vapor closed to control the moisture coming in and out of the structure. And there's a few links to some products there that deliver that. And then the other option is to just use a continuous wet coat of lime or clay plaster and make sure that's taped to the junctions of your other air tightness strategies and to your windows and stuff like that. Things to consider are service voids, because if you have a service void, you avoid all the stress of laborious taping around every penetration and socket. And it also means that if you're hanging pictures, etc., in future, you don't have to worry about damaging airtight membranes. Once you've increased the airtightness of a building, you need to provide an alternative way to get fresh air to the spaces. When retrofitting, we want this ventilation to be managed so you don't have uncontrolled heat loss through air infiltration. The best way to achieve this is using a mechanical ventilation with heat recovery system. These systems remove stale air and provide fresh air, and they include a heat exchanger. And the heat exchanger removes heat from the exhaust air and uses this to preheat the incoming fresh air. So you get fresh air with minimal heat loss. You have the added benefit of filtration. So you have a filter on the inlet and that removes pollutants, pollen, particulates, things like that. They come in different shapes and sizes, including centralised units, where you have a single MVHR unit with ductwork taking fresh air to rooms and exhaust air away from rooms and delivered by discrete vents, which are mounted on the walls or the ceilings. If you have limited space and don't have room for a large MVHR unit, then a decentralised system might work well for you. They are similar in appearance to bathroom fans, extract fans, and each unit then contains a heat exchanger. They are placed on external walls to bring fresh air in and exhaust air out, and they can be used individually, or some systems allow you to interconnect various units to create a whole house system using software. And then quickly, just a few slides about heat pumps and renewables. There's a misconception that heat pumps don't work in older buildings. While it's true that a heat pump will run more efficiently in a well-insulated home, this is true for any heating system, such as a gas boiler. The key thing with heat pumps is that they usually run at lower flow temperatures, and so they need larger radiators, or they work particularly well with underfloor heating. The COP, or the coefficient performance, describes the efficiency of the heat pump. Heat pumps, through the use of a heat exchanger, are able to deliver heat incredibly efficiently. A COP of 3 means that for every 1 unit of electricity used to run the heat pump, 3 units of heat are produced. This means it has 300% efficiency. And for comparison, the most efficient gas boilers are about 96% efficient. There's data now from various surveys to demonstrate high levels of satisfaction for people who've replaced their gas boilers with heat pumps, including more than 80% of households saying they're satisfied with their new heating system. And this carries across house types and also across levels of renovation. So the satisfaction is similar, to, even for houses that have had little or no refurbishment work done as part of the installation. And a key thing is that if you're looking to decarbonise, a heat pump is a really effective way of doing that, because they can offer carbon dioxide savings of up to 2,900 kilograms a year compared to a gas boiler, and up to 3,700 kilograms a year of carbon dioxide compared to an oil boiler for an average house. Renewables can be a great way of reducing energy consumption in historic buildings. They're generally completely reversible and are a way of building on the tradition of adapting with the times that keeps our historic buildings relevant, functional and viable in the context of a climate crisis and rising energy costs. You can make the most of the resources you have available and choose the renewables that will work best in your situation. Solar is generally the cheapest option. It can be installed on roofs, even in conservation areas, under permitted development rights. But if roof-mounted solar is not an option for you, you can install it on outbuildings or pergolas, or even have it ground-mounted in your garden. Solar works well with electric heating systems like heat pumps, and you can also connect the system so that excess power runs your immersion heater to give you free hot water. If you are generating extra power, you can sell it back to the grid using the smart export guarantee, but the rates aren't great with that. So it might be worth considering battery storage, as the cost of batteries has come down as the technology has become more mainstream. And then just a note about this beautiful photo. It shows the recent installation of solar panels on the roof of King's College Chapel, thanks to Stacey Weiser for letting me use her photo. It's a great example of how renewable technology can play a part in decarbonising historic buildings and estates. And there's over 400 panels now installed on the chapel at King's College, and this will reduce the Kings's carbon emissions, by more than 23 tonnes every year. And then quick slide about Enefit. For those of you who are interested in Passivhaus, Enefit is the Passivhaus Retrofit standard, and it's considered the gold standard for energy efficiency in buildings. It is considered this because it sets really strict standards for performance, including heating and cooling demand, energy demand, air tightness, and overheating frequency. The retrofit criteria is slightly reduced from the Passivhaus standard criteria, as it can be hard to achieve the Passivhaus certification criteria in an existing context due to the constraints of working with an older building. The key thing to note about Enefit and Passivhaus is that they eliminate the performance gap, which is the difference between the designed and actual energy performance of buildings. And this is done through data-driven design, modelling the building very accurately, and quality control during construction. Both require the building to be modelled in Passivhaus planning package by a certified Passivhaus designer, and they also require on-site certification by a certifier, so the design and the construction is monitored very closely. And then just a quick stat here, just to show how effective this can be. So heating demand, which is the energy used to heat your home, is measured in kilowatt hours per metre squared per year. The maximum heating demand for an Enefit certified project is 25 kilowatt hours. The average UK home uses 145 kilowatt hours, and the average new build uses 50. So it really shows how effective retrofits can be in terms of reducing the energy demand of buildings. And then here we have a break for questions.
Thank you. Right, okay, there have been a couple of questions in the chat. One of them, I don't know if anyone's going to be able to answer this, is of the 20% of UK building stock built before 1920, what percentage is listed or in a conservation area? Do we roughly know that, maybe, between us?
I do not know the answer to that, but it's a really interesting question and I'd happily look into it. But Paul might know.
I think that's quite fiendish, isn't it, to ask that?
Paul does not know, but I can tell you that there are about 400,000 listed buildings and 9,000 conservation areas-ish. But I think probably it's a very challenging thing to calculate because each building, each area is entirely different. So I think you'd probably, if you started doing the maths, you'd end up with something that's probably quite inaccurate. So it's an interesting question, but I'm not aware that there's an answer to it at the moment.
I think the thing is, don't assume if you buy a house or looking at a house that it is in a conservation or isn't, but to check out.
I think
Yeah.
one thing I would just add is actually listed buildings. There are lots of them, but they are a tiny proportion of our overall housing stock. I think probably it's really useful to just bear in mind, as Annie's saying, that there's a huge body of housing stock which isn't listed, that is still historic and of traditional construction. So that's the big, probably the challenging bulk of what you might come across, I suppose.
Thank you.
Is this Paul, or can I just quickly ask something for Paul? Is there somewhere that people can go online to check for listings and or conservation areas in Cambridgeshire?
I think there was a link somewhere already.
Yeah, there's in the slides earlier, there's links to the National Heritage List of England and also to the conservation area appraisals in Cambridge.
Yep, so the listed buildings, you'd find them on the national database. The conservation areas would be by district area. So if you find yourself in a different district to the ones I'm representing, then you'll need to find the relative website relevant.
Excellent.
Thank you. Okay, so next question was, I have a grade 2 listed building client who's proposing a wood burning stove. I know it needs consent, and I've done this work before, but the fitter is saying that due to HETAS requires an air vent or air brick. Is that true for listed buildings? The building is naturally drafty. That's a good point. Does it require an air vent or
Sorry,
air
I'll
brick?
unmute myself there.
I can answer that, but not
Yes.
hyper specifically.
Oh, sorry. Yeah,
Go
no,
ahead, Ben, sorry,
HETAS, they are. If HETAS are suggesting it, I would strongly suggest that you go with what HETAS is suggesting. They surprisingly, even room sealed appliances still can take air from within a room, so that you still need makeup air. The other thing is that the ventilation is also to dilute any carbon dioxide that escapes from when you're refueling your stove. So I would strongly suggest, even if there is you're living in a leaky building. I mean, you can do a ventilation. They do an anemometer test on the stove to make sure that the air does flow through the stove, and it does. You do get the right sort of a level of draw through the chimney. But yeah, see, if HETAS is saying that you need to do it, I would strongly think that it's a wise thing to do.
Thank you. Okay, I'm just going to read out one more question that we're going to have now, because I'm aware we've just run over a little bit, and then we'll have some more at the end, and we can spend a bit more time after 8:30 if we want at the end going on. So the next question is, how are energy improvements balanced against preservation of a traditional building? How are energy improvements balanced against preservation of a traditional building?
Shall I take that one?
Please do.
Okay. I mean, I think it's a very broad question, and the answer is it will vary from property to property. And I think the key thing to consider is whether those energy improvements are sensitive and beneficial to the historic building that you're talking about. So whether the insulation you're proposing is appropriate, whether it's going to protect the structure or damage it, whether, you know, any windows you're replacing perhaps are sensitive and appropriate in the setting that they're sitting in, or whether they would detract from the environment. So it is a balance, and it's perfectly possible to achieve really high performance results in heritage buildings. But the key thing is you need to pay more attention than you would in a modern building, both because of the building physics and because of the heritage constraints that exist to protect the character of buildings and the areas. Is that a good enough answer?
That sounds like a good answer to me.
I hope it's specific enough. It's hard to answer
It is.
at specific buildings.
Okay, thank you. Well, shall we carry on with the presentation, and then
this section is looking at some example solutions, including some examples from my own house, which is a retrofit of a Victorian terrace, which we are still partway through. And the first example we're looking at is how you can insulate suspended timber floors with breathable insulation. And for this insulation, we followed Ecological Building Systems Best Practice Guide, which involved a pro-climber breather membrane, a hemp and jute-based insulation laid between the joists, and then a pro-climber vapor control layer on top, and lots of airtight tape, taping the various membranes to themselves and to the structure around them. We then put the existing chipboard floor down because it was solid enough and we thought we might as well reuse what we had, and then we put engineered oak on top of that. But before we began any of the insulation work, we had loads of prep to do. And it's worth noting that our house is a very basic Victorian cottage, not a fancy one with bay windows and high ceilings and decorative features. And so everything has been minimally engineered. We had a subfloor void that was less than 150 millimetres, which is the bare minimum you need to ensure effective ventilation under the floor to stop your joists from rotting. So we had to dig down to achieve that, and we couldn't dig down any further than 150 millimetres because we then hit our foundations. We had one single air brick at the front which had been blocked up, and we don't have cross ventilation, so we dug a trench to expose the air brick and to provide ventilation under the floor, and we also knocked a hole through the wall to put a second air brick in, and I think I will also do the same on the other side of the door when we remove some concrete to get a third in as well. You can see the hole we knocked in the bottom right photo there. That was quite a kind of laborious job. You can see in the photo we have lots of sleeper walls running to support our tiny floor joists. There were a few holes in these sleeper walls previously, but we knocked more in because we needed to ensure that there was air movement under the floor once the gaps between the joists had been filled with insulation. Here are some photos of the various membranes going down and the insulation between the joists, and then the breather membrane underneath, all the tape, and the vapor control layer on top. And lesson learnt from this process was that it actually may have been sensible to have another layer of construction, which would have been a layer of chicken wire under the breather membrane, because one time I was sitting in our living room and I could hear, I think, a mouse chewing through the membrane and the insulation, and there's nothing we could do to find out what was going on because we would have to remove built-in furniture and a finished floor. So I just jumped up and down where I heard the noise, and it stopped, and I haven't heard it again since. But I can see why this material would be tempting for mice, and there's very little you can do to stop mice running around underneath Victorian houses. So I think next time I do it, I will put some chicken wire underneath to protect against that. And then solid floors. They're slightly more complicated from a breathable perspective, and that's basically to do with the drying times of the types of screed you need to use, but I'll come to that in a minute. The key question is whether you can lay a new insulated floor on top of the existing floor, or if you have limited headroom, you need to protect ceiling heights, or you don't want changes in level across the house, then in which case you might need to dig out and lay a new floor, a completely new floor. There's two options that I've looked at previously. One is to lay hempcrete blocks directly on top of your existing floor finish, and they provide the insulation, which then you can pour a lime screed on top of, and then use a breathable floor finish. So, for example, stone tiles or timber floorboards. If you do need down, you can use compacted recycled foam glass, and that provides both the structure and the insulation. And then again, you pour a lime-based screed on top of that. In both options, it's sensible to use a cork perimeter insulation around the screed to help reduce cold bridging. And then it's worth bearing in mind that lime screeds take a really long time to dry. They can be walked on within a few weeks, but can take months to dry fully before you can progress and put finishes down sometimes. And so this really needs to be considered from a programming perspective, and that's what makes insulating solid floors with completely breathable construction slightly more tricky than suspended timber floors. And then on the side, you can just see on the left, that's the recycled foam glass going down. On the right, those are hempcrete blocks being laid for insulation. Another example for the walls this time is from our own house. We had to insulate internally. We're in a conservation area, so we had to put the insulation inside, and we have a tiny house, so floor area was a consideration. We used Thermofleece Ultra Wool, which is a blend of mostly sheep's wool, but has a small percentage of recycled polyester fibre, which gives a higher thermal performance than the pure wool blends. And we installed 2 layers of this between battens, which ran horizontally for one layer and vertically for another. And this is to minimise cold bridges. We thought carefully about our batten layout to make sure we had enough places to fix the board, window linings and radiators too. And we packed as much insulation in around the window reveal as possible to try and minimise cold bridging around the window reveal. We used Thermoflox VSD, variable surface diffusion membrane, and tape as the airtight layer, and we had to tape carefully around all the junctions. Here is a photo to show just how complicated it can be to tape effectively in existing buildings where you have joists and existing pipe runs to contend with. This is just one of the now 30+ floor joists we've taped around, and my partner has become a very good on-site airtightness champion. We didn't have space for a service void, so we also had to tape very carefully around the sockets, and we will have small cold bridges where the sockets are as the insulation depth is reduced to accommodate them. The other kind of compromise we made was that we had to use plasterboard rather than the breathable board, and this was basically down to cost, availability, and also ease of installation from a DIY perspective. We used the thinnest board possible, and we just taped and skimmed the joints, and then we painted with breathable paint. So far, we've had no problems with damp or moisture buildup in the structure, but it is a slight risk with using plasterboard rather than a kind of wood-based or a hemp-based board instead. And then that's just a picture of the window lining going in. Talking about windows, there are lots of options for upgrading windows in historic buildings. A particularly budget-friendly option if you already have double glazing, but if it's old and the seals have gone, you can just replace the glazing units. This can significantly improve their performance, and a properly sealed unit with high-spec glazing and an argon-filled cavity can make a huge difference. In listed buildings where it's not possible to replace the windows, sometimes secondary glazing is an option, and that involves installing a second high-performance window behind the first window. Secondary glazing options have improved dramatically over recent years, and there are plenty of well-designed options that are unobtrusive and discreet now on the market. Similarly, lots of really nice slim profile metal framed or composite windows on the market as well. Crittall, who have been making windows since the mid-1800s, now make a thermally broken version which prevents cold bridging through the frames, and you can see an example of bespoke Crittall windows, modern Crittall windows installed in a historic building in the photo on the left. And then in the photo on the right, for really high performance solutions, for example, if you're trying to achieve Enofit, but you have conservation constraints on your property, there are options for mock sash windows, where you require the aesthetic of a traditional timber sash window, but you need to achieve really good airtightness. Sash windows, because of the mechanism, cannot be really airtight. So these windows basically have the aesthetic of a timber sash window when closed, but one of the sashes or the the kind of panes is actually, it's not a sash, but it's a tilt and turn window, and these can seal really tightly when closed. So it gives you the performance of a really high-tech modern window, but with the aesthetic of a traditional timber sash. And then I could talk for hours about all the different ways you can insulate different parts of historic buildings, but we don't have hours. So I've included some really useful links from Historic England, who have this set of brilliant documents which cover different types of construction and appropriate insulation types and techniques, as well as some sort of general information on historic buildings and some of the issues that you might face when you're looking at retrofitting. The other thing to mention is there will be a part 2 of this talk in the spring, and that will include looking at 3 open eco-homes case studies which involve retrofitting historic buildings, with the architects talking about each of the projects. And the panel will talk about the interventions that were made in each case and the lessons learned from the process. And I think that'll be a really interesting talk with some practical examples of some of these things in real life in local projects in Cambridge. So that's that. I'm going to pass over now to Madeline from Action on Energy, who's going to talk about Cambridge County Council's work in retrofit.
Thank you. I think next slide. Perfect. Yeah, hi, I'm Madeline Foster, the Retrofit Project Officer in the Climate and Environment team at South Cambridgeshire District Council. So I'll be talking to you about Action on Energy, which is the branded name for the Cambridge Energy Retrofit Partnership. This partnership includes South Cambridgeshire District Council, Cambridge City Council, Cambridgeshire County Council, Huntingdonshire District Council, Fenland District Council, and East Cambridgeshire District Council. Together, we have made the Home Energy Efficiency Framework Action on Energy, which administers retrofit funding schemes, provides energy efficiency guidance and information, and provides direct support to our communities. We've also procured retrofit contractors together as a framework. Next slide, please. Thanks. The central hub for our information and advice is the Action on Energy website. We have more detailed information about our framework and a page on current funding schemes, including both schemes administered by ourselves and by central government. We have a guidance and installation page with an energy efficiency booklet, a retrofit guide, retrofit case studies, information on contractors, and local external resources for additional advice. On this page, we also have information on building controls and planning, as well as key installation protections to look out for if you're going to be embarking on a retrofit. Other website pages include a wider support page, a news and events page, and a get in touch page. This last page includes our grant funding request form where residents can apply for funding directly. It's important to note that we're also reachable by phone for those who do not use the internet, and we can relay any information that's on the website as well as just provide advice directly. Next slide, please. A key website feature for this particular discussion that I've just mentioned is the planning and guidance section under the guidance and installation page. I've added some screenshots. If you could just click one more time on the page for you to see. Yep, there it is. It's been designed so that it's easy to immediately see if planning permission would be required or not in different retrofit scenarios, with a click down option to provide more details in the case that permissions may be needed. This is a good first port of call when determining if your plans are permitted development or not. And the page also provides other advice, such as information on listed buildings, as you can see there on the screen. Next slide, please. I'd also like to quickly mention some funding opportunities. Our main funding scheme currently is the Home Upgrade Grant 2, also known as HUG 2 funding scheme. I mention it here because we have applied this grant to homes in conservation areas as well as outside of them. This is for homes that are not heated by mains gas, have an EPC of D or below, and meet certain income eligibility criteria. Some of the available measures under this scheme are listed there on the right. When owner-occupiers qualify, all agreed upon measures are fully funded, and when a tenant qualifies, the landlord is asked to contribute 1/3 of the total cost in order to proceed. The scheme has run from April 2023 till the end of March 2025, although applications do close on the last day of December this year. In case you don't meet these criteria, it may be worth having a look at other funding schemes listed on our website on the funding page. These include ECO4, the Great British Installation Scheme, and the Boiler Upgrade Grant. Next slide, please. Lastly, I'd just like to encourage you or anyone you know to feel free to get in touch. We are here to help and point you in the right direction on your retrofit journey. It's also really important to get in touch if you feel you're unable to heat your home to a safe and comfortable temperature year-round. My contact details are listed on the screen, but they'll be available again on the shared contact details page for everyone who's presented today, so you can get it from there. Thank you.
Okay, great. And then now James is going to give us a little introduction to Cambridge Retrofit Hub. So I'll let you take over, James.
Thanks, Annie. Yes, I was. And most of my presentation will be me now saying, next slide, please, because I'm just going to quickly whiz through these. So yeah, thanks very much. Yeah, next slide. So yeah, Cambridge Retrofit Hub is a cooperative and community benefit society. Next slide, please. We've set up to fill a gap that is for homeowners who don't really fall under grants and funding scheme. So it's that gap of the market, where the particulars are to enable homeowners to radically reduce their use of fossil fuels and improve the energy efficiency of their properties. And next slide, please. We are setting up. They've all gone very funny colours, but it's absolutely fine. So we are doing three things. We've got a retrofit service, which is assessment, design and coordination. We're doing training education, and we have an exemplar project. I'll quickly, or even quicker, talk about the retrofit service and then the exemplar project. So next slide, please. And then again, please. So the assessments, so the retrofit service includes assessment. So that's a medium-term retrofit plan. Retrofit assessors will come and assess your property and take you through options of how to put your retrofit together. So that's assessments. The next slide, please. Design. There's the design of the retrofit. That's fairly straightforward. The next slide, please. And then the coordination. So that's the retrofit coordination. So providing a coordination service on site. Next slide, please. Thanks very much. So the exemplar project at 77 Gravel Road, it's just demonstrating how a typical 3-bed semi-detached house can be retrofitted and meet a number of standards, in particularly the AECB retrofit or carbon light retrofit standard. Next slide, please. These are some of the things we're doing to it. There's external wall insulation, loft insulation, suspended floor insulation, air source heat pump, MVHR, new windows and doors, solar PV and battery. Next slide, please. That's it. And if you'd like to get in touch, there's our telephone number or email address. You can get in touch with us there. There you go.
And I've also just put together a contact detail slide, again, that will be shared at the end with the presentation with the details for the presenters. So you can find them all in one place, hopefully. And then we'll move on to the questions.
Okay, so we have a question from Wookie. Do we know what level of retrofit is typically achieved in solid wall buildings in terms of kilowatt hour, meter square year? What fraction get to 50, 100 or 200? Presumably the answer is different for listed 1 and listed 2. What are people sort of normally achieving?
So the easy answer to that question is that the building regs stipulate the target U value for retrofitting thermal elements. So if you're renovating a thermal element, the building regulations say for a wall, you need to achieve this U value as a minimum, for a floor this, for a ceiling this, et cetera, et cetera. The answer to the kilowatt hours per meter squared per year is completely dependent on the property and all these other different types of measures that are installed, including MVHR, the windows, the orientation of the building. And to understand the energy performance of a building, you need to make a really, really detailed model of it, which is when either something like the Passivhaus planning package or another system like that would be used. So, and you'd input all the data, including the geographic location of the building, any overshadowing from trees or other buildings, the surface area to volume ratio of the building. So it's a really specific process, and to get an accurate answer, you have to model the building. So the kind of minimum standard for retrofit of thermal elements, so that's walls, floors, roofs, ceilings, windows, is set by the building regs, and that is generally what's achieved at the minimum, although there are exemptions in existing heritage properties where if for some reason you can't meet the standard as a consequence of cost, or because it's going to take up too much space, or because there are heritage constraints that stop it being achieved, then you don't have to meet it.
Thank you. I'm learning a lot that architects don't just colour in pretty pictures of buildings. They have to know all sorts of maths and stuff.
Yeah.
Very exciting. Okay, next question was from Chris. What is the current position for listed building consent for 1, solar panels on the main structure roof, and 2, double glazing? And does the answer to the question differ if the building is listed grade 2 star and 2? Is that a thing?
Paul, do you want to take that one?
Yeah, we'll do. So there are lots of aspects to the answer. I suppose most likely you would need listed building consent, so that would be probably answering that question. And you might also need planning permission for solar panels. I think you'd be looking for a discrete location for solar panels on a listed building. That would be my general advice. There's often an option for slotting them in, finding a place where they work. I think there are other things we like to think about in terms of solar panels on listed buildings. For example, any structural considerations, the effect that the panels might have on the material and the makeup of the roof. There are options in terms of design and detailing, for example, matte black ones with a low profile mounting system, so they sit close to the roof and are more discreet, with black edges and black fixings to just make them look neater and more discreet. So that's a sort of general sense of what we would be looking for with solar panels. Double glazing, I think windows are a huge topic. I think understanding what windows are at the moment, what their contribution significance are is always the first thing to think about. And then as Annie pointed out, there are numerous options for upgrading windows, whether they're old or new, or whether secondary glazing is the best option. There will be something that can be done to upgrade the windows and make them perform better. I mean, I think there's evidence that will say that actually just cutting out drafts will make a radical, a noticeable improvement before you start doing anything more radical. It would be very much worth referring to the Historic England guidance, which I think a link has been posted. That's the guidance from this year, July, on adapting historic buildings. That has tried to set out strategies and sort of consent issues for common projects. So that would include these ones mentioned here. So I would definitely consult that as a starting point.
Thank you. I would just say we had a home featuring in our tours last year, a Victorian barn that had been retrofitted, and the solar panels that had used like these solar tiles, and you just couldn't tell. It was like magic. I'll just pop the case study in the chat. It was very cool. So I do have a look at that. Okay, sorry, let me get back. Annie, what was the finish depth of your wall insulation? Are there new thinner technologies coming online for insulating walls internally? I think Wiki's put on that aerogel.
The finished depth was, so we stripped back the existing plaster, which kind of gained us an inch, And then we put 120 mil of sheep's wool on. We used 9 mil plasterboard, and we just taped and skimmed, so that added a very minimal depth. So we were kind of in the region of 130 mil. I would say that I was worried that losing that depth from the walls would make a huge difference, and I've been completely proved wrong. We're a mid-terrace, so obviously that reduces the number of walls we have to insulate, because we've only got the front and the back, which are the external walls. But what we've lost in space we don't notice, and what we have gained, which I kind of thought would be nice but has turned out to be really nice, is as our walls have got thicker, we've got deeper window sills, which are almost deep enough to be kind of window seats, or at least are big enough to put a pot plant on or something decorative. Whereas before we had kind of silly little strips of like sort of 5 centimeters for our windowsills. We've now got decent windowsills, and actually the benefit we've gained from that in terms of the actual usable space in a room, in terms of having display space or like a window seat, is huge. And what we've lost in terms of sort of 10 to 15 centimeters of space, I genuinely don't notice it.
Thank you. You're going to find yourself putting all sorts of nonsense on those now.
Yeah, that is the problem.
Yeah.
Pot plants is a problem. We have lots, and then they make more pot plants, and then you have more pot plants, and you only have a small house.
There's another question about your
Sorry,
home, Annie.
Fran, can I just ask, fill in about the thinner technologies, and then
Oh yeah,
yeah.
sorry, James. Yeah.
just pipe up to Wookie as well. So, firstly, yeah, thinner technologies. I mean, there are a number of things out there. So there's, I mean, sheep's wool. I don't know if sheep's wool's got a worse U value than wood fiber insulation or sort of or comparable. And then looking at aerogel. So aerogel is a thin blanket, and generally I guess it's comparable of maybe about a quarter of the depth. I would argue that there are a number of cases where actually people do need the space that badly, Wookie. Particularly if you live in London, or you live in a heritage property, or if you've got a significant amount of detailing internally as well. If you've got particular timbers around the window, if you're taking off the plaster and putting on aerogel, you can actually, there's potential to get it back on there as well. So I would say, yeah. So those are the two things. Aerogel is applicable, but yeah, probably not everywhere. Yeah.
Thanks, James. That's really helpful. And sorry, I forgot that. Yeah, aerogel is a great product. It's considerably more expensive than the other insulation products on the market. So it's like definitely worth bearing that in mind. But when it's been used, I've seen it used on kind of window reveals and smaller, harder to insulate areas where depth is a real concern, but it would have been prohibitively expensive to use it as the kind of primary insulation method for the entire external walls of a property. But definitely it's worth bearing in mind. I don't actually know, because I've never had to look into it, whether aerogel is breathable or not.
Yes,
and
it is.
It is. Okay, great. There
Yeah.
you go. Perfect.
Okay. The minds we have with this. Okay, thank you. And what was the energy target you set for your own house, Annie?
Yeah, that's a good question. We didn't
not having the wind whistling through, basically.
Well, yeah, exactly. We didn't really set a target, which in hindsight is silly. Like we've been working on the house for a long time, and I have in the meantime qualified as the Passivhaus designer and been kind of more conscious of the standards that exist for retrofit. We have been quite careful about data monitoring, so we know we're not finished yet. We've still got about a quarter of the house to kind of seal off, and we've currently cut our gas use by about 60%. We've been really careful about air tightness throughout the project. So and you can retrospectively apply for Enefit certification. So I will model the building, and I will see if we would be close to it. And if we are, then when we do the last stage, which involves an extension, I'll work extra hard to make sure that we can achieve that if we're close. But the main justification was just that, like, we had an old house. It was incredibly leaky. We were using gas to heat it initially. We will get a heat pump when we do the extension. And I felt incredibly guilty about essentially using fossil fuels to heat the outside air. And so I was compelled to insulate for that reason, and it wasn't about setting a target, it was to just reduce the carbon footprint, reduce the energy demand. It's kind of since we've started that we've been actually kind of monitoring the performance and kind of thinking about those targets. So basically we weren't very organised.
Thank you. Don't worry, we've penciled Annie in for being an Open Eco Home tour home at some point when she's finished, so you'll get the chance to it. Okay, we've got a question. I have an Edwardian semi in central Cambridge in a conservation area, like a lot of them are in Cambridge. There's no opportunity to install solar due to shading, etc. The rules for heat pumps about needing to be certain distance from neighbours' property, being more than 1 metre from a boundary, mean that it would not be possible. It would have to be in the middle of the garden in the house. Any advice on how I can improve the efficiency of the house, and in particular remove the current dependence on gas heating? I saw that Margaret Reynolds had sort of replied a little bit in the chat that she's put one a sort of set back in a hedge, but I'll just throw that out to you guys as well.
Sure. There are creative ways of getting air source heat pumps into gardens so they don't just look like a kind of air conditioning unit in the middle of a lawn. So I wouldn't write that off, but there are also other alternatives. I mean, I think I would encourage you, if possible, to look at the fabric first. So look at insulating, if it's possible to upgrade windows to reduce the energy demand in the first place. That's kind of applicable advice in any context. But then there is a product on the market called the Zero Energy Boiler, which is often called ZEB. It is essentially a heat battery. So it has a large thermal mass inside it, and it uses cheap electricity to heat that battery when at times of the day when electricity is cheap, and then kind of uses that to radiate to heat to run your heating system basically. And it's all electric, so it's obviously run with electricity, which is lower carbon fuel than gas or oil. It doesn't qualify currently, as far as I'm aware, for the government grant for heat pumps, but it is an alternative. If you cannot have a heat pump, you can look into that, because it does at least serve the point of decarbonising your heat source, and also it is able to kind of capitalise on cheaper energy prices at different times of day in a way that other electric heating systems aren't necessarily able to do.
Thank you. Okay, thank you. And I think Wiki's put on there that those are the MCS rules as well. So you should always check with planning whether if you don't go for the grant particularly, there might be other ways that you can get around planning. Okay, thank you. Are there any other questions? Sorry, one of my screens has just died, which is a bit annoying. I don't think so. Oh, hang on. Annie, can you talk about your choice of windows? I believe we can see the new windows in your house. Are they simple with no mullions or sash effect? I think windows is quite a sort of big question, really, whether we should have that sort of sash effect. What's the sort of balance that we have to make with it?
Yeah, so we've only replaced one window in the house so far, and we will replace other windows. We will obviously have new windows when we extend, but it's a tiny house. It's got 2 external walls, so we actually have kind of 4 windows basically, or like a few more, but it's basically kind of 2 windows on the front, and there were 2 old windows on the back as well. The windows on the front had already been replaced with pretty awful UPVC, which we still have, and in an ideal world, if budget allows, we will replace them. I would look at something like those mock timber sashes as a first port of call, but I would be looking to avoid having mullions and transoms if possible, because generally, from an energy perspective, you want to be maximising the solar gain you get through your windows, and mullions and transoms interrupt that, and also they reduce the efficiency of windows generally. But that's a kind of question for a later date. But in the meantime, what we did do was replace the glazing units, because we have 80s UPVC. It completely failed, and in the winter the windows were full of condensation inside the panes, which is a clear sign that they're not working as they should. They were smaller, the units were kind of thinner than contemporary double glazing. So we had to go for a slightly different spec to kind of standard modern double glazing, but we have high performance glass, we have argon filled cavity, and we have a U value of 1.4 on our windows now, whereas previously they were probably close to, they were essentially performing as single glazing, and they probably had a U value of about 4 or 5. And we no longer have really serious condensation problems in the winter. If it's really cold in the bedrooms, we sometimes get a little bit, but before it was kind of dripping. On the back, we have a triple glaze composite timber aluminium window. And the intention, and again, no mullions, transoms, and the intention is that we will do that with the glazing on the back, which is less sensitive, although relevant from a conservation perspective. It's less sensitive as it's not visible, and also it will be in a contemporary extension. The other historic window is currently covered by a lean-to utility room, so that essentially covers, it's kind of a buffer in terms of thermal performance, but that window will be removed as part of the extension work.
Thank you. We're looking forward to seeing it now. Okay, and I think the last question, which is for Paul, which is, what's the Cambridge Conservation's view on vacuum glazing, Finio or Landvac, etc.?
Yeah, it's a hot topic, and we get more and more proposals for vacuum glazing, because if you're not familiar with it, it's ultra slim units that it's not double glazing, so it wouldn't fail in the way a double glazed unit would. It's slim enough to fit into frames with traditional proportions. It has a extremely impressive U value. We're all sort of learning, but I think you have to understand that those U values might not actually apply in the context that you're putting them. So, for example, if you were retrofitting in vacuum glazing into an older frame, you wouldn't have the benefit of the U value from the frame. So actually, given that it's a very expensive solution, probably in most cases, it might not be the best one for you. Other things worth thinking about is the Finio option, which is the one I see the most, it has dots across its surface, which you can sometimes see, sometimes can't, but there is actually part of its manufacturing process results in a grid of dots. The others, I think Landvac, Pilkington, have a gasket system, so there will be a gasket in the corner of every single pane, so a kind of little unit, which you can sort of, might be discreet, you might be able to hide that. It's not the most attractive thing. So there are a few different things to think about. Another challenge we're having is the preference with listed buildings is to have proper glazing bars rather than stuck-on glazing bars. So glazing bars that run through the glass. That's much more challenging with vacuum glazing, and the manufacturers are not keen to do that. So a few different things to think about, but we have definitely approved it and agreed it in lots of different places. And but there's an element of caution because I think everyone's still learning. Hope that helps.
Thank you. Thank you. Okay, I'm aware of the time, and I don't think we've got any more questions coming in. So thank you, everybody. Thank you, everybody, for coming and listening, and thank you to our amazing panelists for coming and talking. And as Annie alluded to, we'll hopefully be putting on another event in the spring to take this conversation further. So watch out for that.